Namaskaram, welcome to episode 22 of Machine with Mayank, and today we are exploring PaliGemma. So PaliGemma models have multimodal capabilities and they help you generate outputs using both text and image input data. And you can use image data with these models to provide additional context for your request or use the model to analyze the context of images. So in this tutorial, we will see how to use PaliGemma with keras to analyze images and answer questions about them, right? So I'll just show you how to run it. And so first of all, you need to download the PaliGemma Casual LLM. So it is a pre-trained PaliGemma variant for casual visual language modeling. And so before we begin, we need to set it up. So what we can do, we can go and log into our Kaggle account because we'll be using the model from there. So once you go to Kaggle, log into Kaggle account, and there we can search for models. So this is, then you can go to PaliGemma 2 model card, right? So here at the right side you will get an option for request access. Once you do that, you consent. So here I've already consented. Once you consented, then you'll be able to use the model. All right, so here you can see you are seeing the model, so accordingly you can use whatever model you want to use it, right? We will actually try 3B to 24. This is what we'll be trying. This is the latest one, right? This is the model which we will be using to demonstrate how it works. And once you do that, you also have to use the API key of Kaggle because we will be using Kaggle with our Google Colab notebook, right? So what will happen that you will go on the settings page and then you will create new token. So you will once you do that, you'll be able to download a JSON file with the name. You will be able to download the JSON file with the name and the username and the API key, and that you can set it up in your keys section in the Google Notebook. As you know, we can always store the API keys. If it is Gemini API keys, you can directly import keys from Google AI Studio, but here we need to create Kaggle key. You have to use the same name, Kaggle key, Kaggle username, and then put the respective values here and done, right? So this is how you will set it up in your Google Colab notebook. Yes, so once you do that, you will click on the run in Google Colab. It will take you to Google Colab. So this particular code of Google has some errors, right? So this is not working as it should. So I have rectified all the errors and now it is working properly. Typical errors which I want to show it to you is that we do not have to use Kaggle here. You can remove this. This is the first error, right? You can just use keras, PaliGemma. You can just use this, right? This is not required. So because of that, some error was coming, so you can ignore that. And once you do that, you have to run the notebook one by one, right? So for me it is already ready, but before that you also have to allocate GPUs to it. So you can click here. You can see that I am using a Python 3 GPU, but in case if you are new, click here, change runtime type. So here we are using T4 GPU. Alright, we are not using TPU. TPU is tensor processing unit, which is very fast. We are working with GPU right now, so we'll use GPU, T4 GPU, and you can save it, and that's it. The connection is done, right? So once you do that, once the setup is done, you will, as all other AI models and how we work with other models, we have to import OS. We are importing from Google.Colab import user data. We need to set up username, Kaggle username, Kaggle key, and Keras backend, we are using JAX, right? It is also developed by Google. It is a AI engine. So instead of using TensorFlow or PyTorch, we are using JAX, and JAX is super fast AI computing engine developed by Google, and it makes AI model run faster and more efficiently. And why does JAX help? Because it is super fast, it can handle huge AI models better than traditional tools. It is good for automatically optimizing and speeds up AI training, right? So it works very well with modern AI hardware, so it can work with powerful GPUs and TPUs. So for example, if you have an AI model training for 10 hours, JAX can optimize it so it runs in just a few hours or even minutes, right? So we are using Keras. Keras used to build the AI model. It is like a Lego set. You bring all the layers of what is required to building a model, and JAX runs that model. So it acts as a turbocharger, right? So now we'll start running this code. So the first thing is, yes, yep, we have to run this code. Kaggle username, Kaggle key, Keras backend. We have to install Keras, right? Now you must be asking what is. I think I explained already. Keras are building blocks. Keras are uh, is a tool that helps in building AI models easily. So it's kind of a Lego set for AI. So you can put together different AI parts like layers, neurons, functions, and you do not need to know all the technical details. Pretty good for me, yes, that's because I'm still learning. And JAX is a computing engine developed by Google. So similarly, you have TensorFlow, you have PyTorch, but TensorFlow and PyTorch are not as fast as your JAX, so we are using JAX here, right? So you will first of all you will install Keras NLP from Kaggle Hub. All right, and then you will import its dependencies and configure Keras. So you will run this command. So see, all this are the dependencies: Keras, NumPy, PL, request IO, matplotlib. You will see why we are using this matrix plot library and import image. Okay, so we'll configure it. Then we'll load the model, right? So to load the model, we are using this function PaliGemma. In that we'll store Keras hub models dot PaliGemma casual LLM from preset, and then we have given the link. So this link is wrong, it will not work. I think I closed the correct. This is not GitHub one. Okay, I'll open the correct Kera file where it actually works. Oh no, I can show the error here itself to you. It's okay. Just have to remove this. It was showing me error earlier, so that's why I'm getting a call. Give me a second. Yeah, so I think it is giving me some error. So I found the solution for this error. Right. So this is. Sorry, yeah. I think we'll just wait to run it. It is now downloading the model. This is what the issue was. We are solving it now. Hey, why again the same issue? Just give me a second. Hi guys, yeah, so I think it is solved some issues, but I don't think now there's any. Right, so you'll use this code kagglehub.model download keras PaliGemma kera, and this is the model which you're downloading. This is not required again. Why did I use it again? Let's see if it is causing an issue. No, it is not required. Cool. So this is how we are loading the model, right? And then we'll use some utility methods. One is to crop and resize the image. It's a helper method for read image. So what this method does, this method crops and resizes the image to the past in size so that the final image is resized without skewing the proportions of the image. And read image helper method for read image from URL. So actually it opens the image, resizes it so that it fits in the model's constraint, and puts it into array that can be interpreted by model, right? Technically it means that image is so it opens the image, resize it according to the model's constraint, and then puts it into array that can be interpreted by model, because model can only understand mathematics, right? So that image needs to be converted into array. So read image from URL takes in an image via valid URL, right? So you need this method to pass the image to the model from where the image is coming. Got it? This is to crop and resize, this is to read the image, and this is to read the image from URL. So this is the input of the images, right? So this is the function, crop and resize function. This is read image function, URL, target size, and bytes input output. Okay, and this is parse, it's labeling. Okay, segment output, image bounding box, segment mask. Okay. See, maths is pretty solid here, which I'm also learning. Hopefully by March end I'll be very clear with that. But for now, we'll have to learn this. We have to understand how this code works. But for the essence of time, we'll just run this code, and then sorry, let me clear this output for you. Right. So this is target size. Here it is interrupt. After loading the model and creating utility methods, you can prompt the model with image and text data to generate and responses, right? So PaliGemma models are trained with specific prompt syntax for specific tasks such as answer, caption, and detect. These are the three things which we can ask them: answer, caption it, and detect it. So we can go and check the system instructions for it. So image URL will store the image URL from where the image is coming. Pow image is a variable where we are storing the image URL and target size, and matplotlib will show the image on the it will plot the image, right? So we'll just run this command. So it has created the image, it has plotted the image. Cool. Now we can ask a question to our friend PaliGemma model. So we are asking answer, where is the cow standing, right? So PaliGemma generate will give the output. Inputs will be image is cow image. Okay. What is the issue? It is not defined. Let me check the code. Something is missing. What is missing? I think some naming convention. I might be. Let me check here. What's the message? Okay. Let's try this. Something is missing. Okay. Okay. Variable is cow image. So we'll use okay. What? Prompt equal to prompt. This we did it correctly. Something is wrong. Give me a second, guys. There's some issue which I'm facing. So guys, I think there was an issue with the model. So I'm re-downloading the model. I think it should help us solve the issue, right? So guys, I think the problem is solved. Think so. If we get the output for this, where is the cow standing? The answer is the problem is solved. Let's see. Yes, yes, it is solved. The answer, where is the cow standing? So it is saying it's on beach. Perfect. This is done. Now we'll see detect prompt. It will detect. We'll check with the where is the cow. We can ask this question. So there's a detect prompt, right? There were three prompts: detect, caption, and one more was there. So this is the detecting. This is an answer. So this prompt we are using answer to know the answer. This is to detect, and then this is to segment, which we'll do afterwards, right? So now we'll run this command. It will show us by detecting where is the cow, and it has also labeled it. It's a cow. Perfect. So I think these two functions are done. Segment prompt uses the segment prompt syntax locate the area of an image occupied by an object. So this is what is done here. Now so this segment, sorry, this is the detect one which we did. Segment prompt is use the segment prompt syntax to locate the area of an image occupied by an object. It uses the Google Big Vision library to interpret the model output and generate a mask for the segment object. So there are three things that is happening. First, it locates the area of an image occupied by an object. It uses the Google Big Vision library to interpret the model output. What is the output? So one is to understand what is the area of the image is occupying an area, so it will locate the area. Second, it will use Google's Big Vision library to interpret that model output. What is the model output? And then generate a mask for the segmented object. Okay, this is the object that need to be segmented, right? So we'll run this particular command. Big Vision library and its dependencies. Colab notion is Big Vision repo. We'll clone this. Hit to install, override and connection. This is what will happen. Hopefully it runs. Okay, perfect. It's done. Alright. Now for the segmentation example, load and prepare a different image that includes the cat. So we'll run this command. So it has loaded an image. Cat is a variable, so it is reading an image from this. It is being image from hugging face space. It is on hugging face. That's okay. Alright. So now it will do the segmentation. You know what the error is here? I'll tell you. This is not the error. Okay, better. Okay, segmentation is done. Use function to help parse the segment output from PaliGemma. Okay, parse means it get the info or from whatever the object is, right? Now we are querying it to segment the cat. Okay, we want it to segment the cat from it. So we'll run this command. Yeah. Okay, we'll run this. The cat has been segmented. Now we want to see the cat, right? So we'll run this command. So see, this is the cat that has been segmented. Wonderful, right? Now these are the batch prompts. Together you can run multiple prompts. See, where is the cow standing? What color is the cow? Describe, segment. So now you can see we had asked a couple of questions by using the prompt format. Answer, where is the cow standing? What color is the cow? Describe, and all that stuff. So um, cow standing on the beach. Sorry. What color is the cow? Brown. In the image we can see a cow on the sand. In the background there is water and sky. Now detect cow. Cow has been detected at this location, and segment cow. So now we will see now. So segmentation has been done. We want to see it and we need to visualize it. So we'll write this code. Cow image is the image name, and then we'll just run it. And bam, it's done. Perfect. It is a bit complicated for me also because I am learning, but I loved it. So I will share the GitHub link of the Colab, which is actually working, the code with the exact code. And I will also share the GitHub link and the Kaggle model card link for you to try it out for yourself. All right, it's great working with you, and looking forward to episode 23 of Machine with Mayank, where we might be working on. Let me see, what would be our next topic? There are a couple of things. Yes, and automation is coming, so it will come by tomorrow, end of the day. Kera we just did. We will be working with Lambda. We will explore Lambda. We will explore Lambda. We will explore LangChain. We will explore Lang graphs. All right. I hope you liked it. Have a great day.